right, so we're ready to dive in. You can't see this in the recording, but that bottom word says Desmos. So hopefully we have our devices with us. I plan to have time at the end to do Desmos. I'm going to start to kind of try to structure classes to do teaching and then also have some review time. So the first thing we're going to do is head our notes like always. Today's date is the 12th all day long. So put your date up here at the top so we can keep track of things.
Wait, today's the 12th?
Yep, of October. Yesterday was the 11th. Saturday was the 10th. Well, you haven't been at school since Wednesday, so... That's exciting. You've been camping and you get to go on vacation. Alright, so our question today, and you don't have to write this down, we're going to start writing right here where it says we multiply to show. You can write all this if you want. But why do we multiply? I know this is not, you get taught sex ed in 8th grade. So no, this is not that question, why do we multiply? That comes next year. Why do we multiply in math? I got you started here. We multiply to show... Yeah, we multiply to show repeated... Yes. Repeated addition. Or we could define it, kind of defining a word with the word. Or multiple... I should see everybody writing this. Or multiple of something. So I'd like you to take a moment and write down a real life situation where you might use multiples, like talking about multiples of something. Like, if I were going to make good on our conversation about donuts from way back when we came back to hybrid, I might buy 5 of a dozen donuts. So if I bought 5 packs or boxes or whatever of a dozen is 12, right? A dozen is just a word for 12. 5 packs of 12 donuts. That would be like 5 times... Sorry, my brain got ahead of itself. It'd be like 5 times 12 equals 60. Right? Sorry, that's a 1. It's real messy. So think in your mind for a second where we use multiplication in the real world. Might be like packs of colored pencils. Might be food. I'm always thinking about food. Really hungry this morning. I could go for a donut. Natalie? Yeah, 2 boxes of 10. I'm going to skip the word granola because, you know, I think I know how to spell it, but I'm just going to save some paper. So that'd be 2 times 10. So that's 20 granola bars. Now, before we move on too far, I'd be remiss, which is a fun word for like regretful. I'd be remiss if I didn't talk about, up here we said multiplication and division. Can anyone remember what I've said about how division relates to multiplication? Similar to subtraction to addition. Can you say it louder?
No, it's the opposite.
It's the opposite, but, well, didn't we say they're the same? But opposite?
No.
Well, didn't we say subtraction is just addition?
Yeah. Did we? Yeah, we did.
Addition of the opposite, right? We can add the negative. So division is essentially multiplication. Division is just multiplying to split something up. So we use multiplication or division interchangeably. Excuse me. So what if we bought a pizza that was 8 slices, right? A normal large pizza, I think, is 8 slices. And I ate half of it. half of the pizza. Well, if the pizza is 8 slices, that's half of 8 slices. Half of 8. My brain's getting ahead of itself. Half of 8 is 4. No, wait a minute. Half of 8. That's the same thing as saying 8 divided by 2. So when we're discussing multiplication, we need to remember that multiplication and division just go hand in hand. They can literally be swapped for each other. We could multiply by 1/2 or divide by 2. Nate, is this making sense?
Yeah.
How we doing, everyone? I know that's like a weird idea. So really in math, there's only addition and multiplication. Subtraction is addition of the opposite. Division is multiplication by a portion. So when we had this definition up here, if we multiply to show repeated addition or multiple of something, I should really put multiples, most likely. This multiples of something, I'm actually going to put a parentheses and put or pieces. Wait. Yeah, same. That's just an E, I think. Guys, I'm a mathlete, not a language arts. I don't know what to. I don't have a good rhyme. I tripped and fell, and there we are. So now multiplication, we also have to use with negatives. So let's say, who plays video games here? Yeah, okay. So let's say Natalie, you go to GameStop. Is that still like a thing these days?
Yeah, GameStop is always a thing.
Okay, so let's go to GameStop, and you buy a video game. What do video games cost now?
$70.
Okay. I knew you guys were going to give me the answer of it really depends. Let's say $50, right? Because that's an easier number to work with. Now, when you buy a game, do they hand you money or you have to give them money? You have to give them money. So if that's like debt, right? That's like loss. So if we lose $50 for every game we buy, and we buy 3 games, I will have lost or spent, or however you want to think about it, $150. But let's say, Natalie, maybe you and Lily have the same taste in games and you decide you're going to go in on a game together and you're going to split the cost, right? So that -50, you decide to split. Well, in math, when we split something, what is that? Division, right? So Natalie, you and Lily divide that between the two of you, and each of you is going to pay how much? $25. Now, since you pay it, it's negative. And this is where those negative rules come into play. I hate the amount of times I say rules. But when we have one negative number involved, divided by a positive, the result stays negative because we took this cost of $50, split it between the two of you, and you each still have a cost. Right? So that's why the negative stays negative. Now, we can also multiply to do the exact same thing. Take your -50, and instead we can say each of you is going to pay what portion of the game? A half, right? Half of. So the portion, and actually up here where we wrote or pieces, a fancier word for that is portions. I need to take these notes a little better. But it's okay, however it works for you guys. Again, this is totally different than I normally teach. So half of that $50 is still that negative 25 where they owe, or they're going to pay 25. Now, the next thing we're going to do is something that a lot of people are getting tripped up on with positive and negative, or not positive and negative. Let's try this over. The next thing we're doing is what a lot of you are getting tripped up on with solving equations. We're not ready for positive and negative on top of everything else. But let's do some one-step equation solving by talking about pizza. So let's say, and if you've watched this on my YouTube channel, ooh, there's my perfect segue to plug my YouTube channel. So it's hard with the masks on to tell who just was exacerbated. That's a great word too. Oh my gosh. But here's why I'm plugging my YouTube channel. If you need help on your homework and you want to see, man, I wonder if somebody else already needed help on this, I am posting tons of quick little videos. Look at these. 2 minutes, 3 minutes, 5 minutes, 4 minutes. When people ask me for help, I make quick little videos and send them back to them. I'm also recording classes, and this is my complicated class I teach to 8th graders. But like, here's the Math 7 class from last week. And your class is being recorded right now. If you need help, well, I can't see you. It can only see me. You can see me down at the corner.
They can hear me.
Well, yeah, they can hear you. That's why I never use your last name. Just don't use your last name. So, if you need help, come on here and look and see if I've done that problem already. The other thing I wanted to make sure we announce is your Khan Academy homework moving forward. All of the new homework. When you redo the problem set, like when you retry it, you will get the same problems over again. So, it won't be as difficult as it has been seeming. Go ahead and write down this equation. I mean, I wish I could teleport. That would be sweet. So, let's say we're ordering pizza, and we dismiss classes by advisory. And we dismiss Pettigrew, and we dismiss Goldring, and we dismiss Allie, and we dismiss Estes, and we run out of pizza. So we have made it through 4 of the 6 advisory groups. And they've gotten pizza, right? So 4/6 of the pizza that we actually should have ordered was 25 pizzas. We ate 25 pizzas. All of you guys that already got to eat ate all the pizza. So we are going to make a quick pizza run to buy the rest of the pizza that we need. But, you know, we're a school. We don't have lots of money. We don't want to buy too much pizza, although I would buy too much pizza and just eat way too much. But we want to buy what we need. So we need to solve what is P. What was the amount of pizza that we should have ordered? This is a fraction multiplied by a variable. 4/6 of the pizza that we should have gotten was 25 pizzas. Sorry guys, I have to keep this on because students sometimes text and call us. Like, I have to Zoom with a student who's self-quarantining just to be able to go to a bar mitzvah in 2 weeks. So after your class, and if I forget, they're going to call me. So that's, if my phone goes off, sorry, my apologies. The reason I'm not reducing this is we have 6 advisory groups, right? So because we're talking about Phoenix, I'm just using 4/6. We could reduce this to 2/3. So I'm sure at least a couple of you are sitting there thinking, why doesn't he just use 2/3? So 4/6 of the pizza that we needed is 25. We want to use inverse operations. Wait, we don't have to. So normally, what we're thinking to ourselves is use inverse operations. But the point of using inverse operations is to get the variable isolated, right? So the purpose, what we're trying to do, is isolate just one p. Nothing added with it, nothing subtracted. The only thing multiplied would be 1. And we actually know a trick involving fractions. If we take a fraction and multiply it by a certain something, we can make it turn into 1. Sorry, this is a C. What do we multiply a fraction by to turn into 1? Nate, is that a hand?
No.
Stella?
I don't know what it's called, but it's like it's opposite.
Starts with re. Lily?
Reciprocal.
Reciprocal. So if you have space to fit the whole word reciprocal, you can. Otherwise, you can abbreviate to recip. An example of this, like a nice example, one half times 2 over 1. The reason this works is we would have gotten 2 over 2. So out here, the reciprocal of 4/6, we flip it. So the refliprical, see what I did there? The refliprical of that is 6 over 4. But remember, when we do something on one side, we have to do it on both sides. Now, 25 is not a fraction. How could I turn 25 into a fraction?
25 1?
Yeah, 25 ones or 25 wholes times 6 over 4. The left side, I'm going to write my in-between in my little like mint color. I don't even know what to call this. I get 24 in the numerator when I multiply straight across, and I get 24 in the denominator when I multiply straight across. The p is still here, it drops down. Equal to 25 times 6, well, 25, 50, 75, 100, 150 over 4. Now, this isn't quite as nice as what we would like. Now, 24 over 24, that becomes 1, because we know any number divided by itself is 1. 150 divided by 4. I know that 120 would divide by 4, so let's try this. If I do 120 divided by 4, I'd still have 30 left over. Right, 120 divided by 4. Well, what's 12 divided by 4? 12 divided by 4 is 3, so we'd get 30 plus, well, how many 4s are in 30? Well, 4, 8, 16, 20. Yeah, 28, right? Because 4 times 7 is 28. So 7, and there'd be a remainder of 2. Now, wait. Can I order 37.5 pizzas or 37.5 pizzas? No, so what should we have gotten? Should we get 37 or 38? 38 with food. We pretty much always round up. So this is the squiggly equals, meaning approximately. Our exact answer would be 37.5. But if we're talking about actual pizza math, and like we're going to send somebody out to get pizzas, we should have gotten 38. That's what P should have been initially. So we had 25. How many more pizzas do we need to go pick up? No, 38 is the total that we should have had. Yeah, if we had 25 and we should have gotten 38, yeah, we need to go get 13 more. Or you can make it a cool 15, just, to have fun. And if we're getting 15, we kind of might as well just get 20. Right? So that would make sure that we have enough. Me? I am normally the person that goes and picks it up if we do a school pizza thing. I mean, now we normally just have it delivered, but like for talent show, we would order like pizza for all the kids doing talent show, and I would go pick it up, and like the whole tailgate of my car was just pizza. And then it smelled like pizza for like days, and I was okay with that because I love pizza. When the car gets smelled up. What question do we have about this problem? Because I'm going to set up another one and have you do it on your own. Isaiah, we feeling good over there? Or you're just like keeping to yourself and staring down, so I'm trying to make sure. I'm just looking around there and trying to make some eye connection. It's easier to tell how kids are feeling when I can see your face. Let's try a weirder one. Because like it doesn't always have to have a story related to it. Let's try 3/8. We'll just go ahead and use P since we were using P. Equals You know what? I'll do 18. There's a reason. Trust me on this. If 3/8 of P is 18, what is all of P? What is 1 P? So if we broke the building, or if we try to think back to the other problem that we just did, if we had 8 groups, 3 of them have eaten. 3 of our 8 groups got pizza. And that was 18 pizzas. Maybe this is summer camp or something. What should P have been? And maybe it's not pizzas. Maybe it's pierogies. Or maybe it's piata. Pineapples. Could be pineapples. It could be something that doesn't even start with P. Alright, solve that on your own. I'm going to ask for help with what to do. I'm still, in that period of letting you guys get comfortable, but again, I am going to make cards for you guys so I can randomly call on people. So, please start to try to get comfortable with raising your hand to interact in class, because pretty soon you won't need to raise your hand. I will just call on you, and you can always pass. So if we were going to use inverse operations, the inverse of multiplication's division, and we'd be dividing by this fraction, which is gross and why we don't want to do that. And last week we talked about keep, change, flip. If you remember back to Wednesday, KCF. So instead of dividing by the fraction, can anyone volunteer to tell me what we want to do here to work towards getting just 1 P? We want 1 P. I can't tell if that's a hand, Monosophy. It's creeping up. And what is that? Yeah, its reciprocal is 8/3. So we're going to now, do I only multiply on the left side? Yeah, we have to do it on the right side also. Now, here is where we're going to see why I chose 18. I want to show you another trick. Not trick. Sorry, another strategy. Another tool. I should stop using the word trick because this is not a trick. It's an awesome strategy. when we are multiplying, pencils down for a second. Don't write this because it's big numbers. I mean, you can write this if you want. Feel free to ignore me when I say that, but I'm just saying you don't have to write this. 8 times 10, if I try to do this multiplication in my head, is 80. 8 times 8 is 64. I get 144 over 3. Now I'm going to need to divide that. I don't know how many 3's are in 144. I'm going to have to work from 120 would divide by 3, and then I'm going to complicate it, right? Here is another strategy. Now you should pick up your pencil and write this. Actually, I'm going to probably change colors. We can do what's called cross-reduce. We can do what's called cross-reduce. Cross-reducing is when we divide the numerator and denominator by the same value. So instead of when we get out here and we would divide by 3 and divide by 3 to try to get the answer over a 1, instead of waiting, we do it over here because we recognize a number on top and a number on bottom can both be divided by the same thing. So 18 and 3 can both divide by 3. So on top, we divide by 3. Please make sure you're writing this work. It won't make sense otherwise. On top, we divide by 3. On bottom, we divide by 3 because we have to keep things balanced. Now remember, I don't know how much work you guys actually did with the giant 1 last year, but anytime the same thing's happening on top and bottom, nothing's actually changing. Just like when we do the same thing on the left and right, that nothing's actually really changing. What's up? You're good.
Do you have an extra dongle?
I haven't used that in a long time. I don't know that I still have one. They might have taken it back with my computer.
Well, now the smartboard has an HDMI cord, and trying to hook it up to the smart camera.
Hey, Sean.
I can't find my dongle.
Do you need a VGA dongle or an HDMI?
HDMI.
Do you have a moment to help Terry out with a tech issue? She needs a dongle for her smartboard. I don't know if she needs VGA. I think she needs VGA, but it might be HDMI.
It's HDMI. That's what comes out.
For the dot camera?
That's what comes out of the smartboard now. It's an HDMI cable. Okay.
No. Here's what's up. You guys get out your computers and load up Desmos really quickly. We'll go ahead and have you guys get to the Desmos site. So go ahead and load up Desmos. I'm going to run over there and help Mrs. Goldring really fast. I'm going to assign this to you guys. Reducing process when we got interrupted. So we want to make sure that we wrap this up. So over on the right side is where we were working. And we said that we will divide the numerator and denominator both by 3. Because like you guys learned last year with the giant 1, when we do something in top and bottom, it keeps things balanced. It doesn't really change anything. It's like working with 1. So when we do that, I'm going to write our in-between in orange here. 18 divided by 3 is 6. The 1 on bottom is still there. The 8 on top of this fraction, nothing happened with. And this 3 divided by 3 is 1. So all I did was drop my fractions down, showing the new values with the cross reduction. Sometimes people like to cross out the old numbers. You don't necessarily have to cross them out. They don't disappear. So I'm going to try to get this to focus again. Sorry, it kind of got itself out of focus, guys. So now the multiplication's a lot easier. The denominator times the denominator is just going to give us 1. And the numerator times the numerator, who knows what 6 times 8 is?
48.
Ooh, couple different answers. 8, 16, 24, double that. I think 48.
Aw.
So guys, literally, I count on my fingers. I did 8, 16, 24. That's 3 of them, and then I doubled that. So we get 48 over 1. Now, we forgot about our left side over here, so we got to go back and clean this up. 8 times 3, 24 on top. 3 times 8, oh yeah, same thing, 24 on bottom. R times P comes down. And what's 24 divided by 24? 1. So we got our 1P. No, not 1 equals. We got our 1P. It would help if I could write. And then that was equal to 48 over 1. Now we're going to clean all this up. We don't really need the 1 times P, but I already wrote it down here, so I guess we have it. And 48 over 1, do we need the 1 in the denominator? No, we can just write 48. And that is why I had chosen 18 instead of 17.
17 is a very good number.
It's a very difficult number. I'm not going to say it's a bad number, but it's prime, and that makes it hard to work with. 18 is much easier to work with, and I wanted to make sure we talked about cross-reducing.
What do you want to do with prime numbers?
I got nothing against them. They just make the math a bit tougher.
Prime numbers.
And I have a little bit against tough math. All right, we got 4 minutes left. I'm unpausing Desmos. Have at it. And for anyone watching the recording, whether Zoom failed tomorrow or whenever we try to Zoom, yeah, your homework is on Khan Academy. It should all be the same question sets, so let me know if you need any help. Shoot me an email. Have a great day. Peace out. Is that how I need to end? Peace out.
Hey.